Ladies and gentlemen, welcome to another episode on the Incredible Academics YouTube channel. Guys, just a second. I don't know what's happening. I just dropped my pen there for a second. Sorry about that. Guys, listen. We are going to continue with inverse functions, but we've already covered. Okay, we haven't covered inverse functions for exponential, right? So exponential functions, that's what we're going to be looking at today. And I hope you guys are doing well. I hope you guys are excited. The same way I am. One of those subjects that I'm passionate about. But anyway, let's get right into it without wasting too much of your time. Look, so inverse functions. So we're dealing with exponential. I hope you guys can see exponential functions. And inverses. So that's what we're going to be looking at. And I mean, we've already discussed, a little bit about the fundamentals of logarithms. So I'm pretty sure you guys are ready, for this. And I'm just going to do a quick recap that if you've got something like this, x is equal to b to the exponent y. X is normally referred to as the number, all right. B is referred to as the base. Y is referred to as the exponent. All right. We're now ready to tackle exponential functions and their inverses. Okay. Now you need to figure out what is the relationship between 1, 2, 3 in terms of logarithms. Okay. Now logarithms say that the exponent is equal to the logarithm with the logarithm of the number, right? And then the base here. Base. In other words, what is the exponent? Y is equal to the logarithm of the number x with base b. Okay, I mean the relationship is quite easy to understand. I mean, this is literally the thing that you guys need to know, to not have issues with exponential inverses. All right, okay, so let's get right into it. So now let's say we're given the function f of x is equal to let's say we've got 2 to the exponent x, which is like the most basic one, right? And you also asked, okay, find the inverse, okay, and sketch on the same set of axes of axis f inverse and f. Do you get what I mean? You need to sketch the two, but I mean, it's super easy for you to sketch the inverse when you've already sketched the main function. So I'm gonna start off by sketching the main function, because literally when you got the main function it's done. So look, the exponential function is like this. The exponential function is like this. It's an increasing function, yes. So we just need to figure out, okay, what's gonna be the y-intercept over there, we know that this doesn't have an x-intercept, and I hope you know why. So here it's going to be 0 is to 1, because if you put a 0 there in place of x, you get a 1. So that's why we put 0 is to 1. So remember, this is the y-intercept of f, and it's going to become the x-intercept of the inverse. Do you get the drill? X-intercept of the inverse. So meaning that for the inverse, we're going to have 1 is to 0 here. So we're going to have something like this. And remember, currently the x-intercept serves as the asymptote. Not the x-intercept, but the x-axis. So remember, this is x and this is y. So if the x-intercept acts as the asymptote, guess what's going to be the asymptote for the inverse? I hope you said the y-axis. Okay, so our function is going to be like this. All right, and really, when a function and its inverse, right, they're actually symmetrical about the line y is equal to x. So this is y is equal to x, and this is f inverse, right? Two function, the main function and its inverse, they are symmetrical about the line y is equal to x. Because remember, this is exactly what you did when you were finding the inverse. You said y must be equal to x and x must be equal to y. You swap things around. Are you guys with me? So now look, we don't know what the expression is going to look like. The expression for the inverse. Okay, so remember, we're given f of x is equal to 2 to the x. All right, so you're just going to swap things around. This is the y, this is the x. So in place of the x, we put the y, and in place of the y, put the x. So this is the y, we put the x, and this is the x, we put the y. Now we've got a situation. We need to make our y the subject of the formula, as we always do with all the functions. Y needs to be the subject of the formula, because that's like the dependent variable. So remember, this goes back to what we were looking at, that y is basically equal to the logarithm of the base of the y, which is the exponent, is equal to the logarithm of the number at base whatever base that we have over there, which is 2. So this is the function of the inverse, ladies and gentlemen. Doesn't look so familiar, isn't it? This is the function of the inverse. And you can use your calculator to find the corresponding y values. You can see that the y axis is actually the asymptote for this function. In other words, this function doesn't go beyond, you know, this line over here. So if you put any negative values for the x, then you're not going to get any defined number. So you can see that I've punched in the logarithm over there. So let's do a test and then sort of like substitute any number which is beyond the y-axis. So base 2, and then the number, let's just say -1. Okay, you see we're getting a math error. Okay, and the moral of the story is that the number here always positive. That number is always positive. So as soon as you start substituting, you know, values that are negative in place of the x, then you won't have issues, right? So yeah. And now let's check, is this inverse a function or not? I hope you're thinking vertical line test. All right, vertical line test. How many times is the vertical line cutting this? Only once. So the inverse of an exponential function is also a function. Okay, so we've looked into that. I'm just curious about a different f of x. So let's suppose that now, okay, we've got g of x. All right, we've got g of x, which looks like this. So it's 1 over 2 to the exponent x. So in other words, we've got a slightly different g of x. Now instead of having a number there by b, we've got, instead of having an integer, we've got a fraction. Let's see what difference it's going to make. Okay, and obviously we need to sketch the g and its inverse on the same set of axes. All right, sketching the g. So what's g gonna look like? So obviously you guys know, if it's like this, that's when it's like a normal exponential function with a base that is an integer, you know, yeah, 2, 3, so on and so forth. But immediately when it becomes a fraction, then we're going to have something like this. It's not supposed to touch the x-axis. The x-axis is actually the x. It's actually our asymptote. 0 is to 1. And if you check, this function that we're looking at here is actually a reflection of this function. F of x is equal to 2 to the x. And obviously it's been reflected in the y-axis, okay? In the y-axis. In other words, x became minus x, and then, yeah, you know, when x becomes minus x, f of x is equal to 2 to the exponent negative x. Then we can say, okay, 2 to the negative x, negative 1 to the exponent x. Still the same thing, therefore 1 over 2 to the exponent x. So there's very close relationship between this function and that function over there. Okay, so the reflection is about the y-axis. But anyway, we're not there. Our focus is on, you know, this function and its inverse. Okay, so this is what we have. This is the main function. But remember, you guys, this is the y-intercept of the what? Of the main function. It's going to become the x-intercept of what? I hope you said the inverse. So it becomes the x-intercept of the inverse. So we're going to have something like this, 1 is to 0. And obviously we're just swapping the numbers around. So, and then there we go. We're going to have something like that. There we go. And the line y is equal to x. It's just that this is not drawn to scale. It's supposed to pass through that, right? This intersection here. It's supposed to pass through that intersection. So this is y is equal to x. It's supposed to pass through that intersection, and it's also supposed to pass through the origin. So you can see that when we look at this line y is equal to x, the two functions are actually symmetrical about each other, because this branch over there forms the mirror image of this branch, and that branch over there forms the mirror image of that branch. Are you guys with me? Yes. So in this branch, because remember with this function, it's still the same situation. The x-axis is the asymptote, this function. But remember, when we're dealing with the inverse, the opposite is going to be the asymptote. In other words, the y-axis, okay, is our asymptote. In other words, this function over here is never going to cross the y-axis, meaning that our x values will never be negative. We'll always have positive y values. All right. Okay, so now let's figure out what the function is going to be, the actual expression for the inverse, G inverse. Okay, so we're going to say, okay, fine, what we're going to do is we're going to say, okay, we are swapping things around. In place of x we put y, in place of y I put x, so x is equal to 1 over 2 to the exponent y. Alright, and then we do our thing. We know the exponent, which is the y, is going to become the equal to the logarithm of what is the number that we're dealing with. The number is x. The number will always be x. And what is the base? The base is 1 over 2. And there you have it, ladies and gentlemen. There you have it. So this is G inverse. This is G inverse. Right, that is the expression for the function G inverse. So guys, this is a very lovely chapter. I'm actually enjoying it, and I hope you guys are enjoying it as well. Yeah, and I'm thinking we're gonna leave it at that. I mean, the domain, let's talk about the domain and the range. But I mean, if you can figure out the domain for this and the range for this, you know, it's all done. You know, it's all done. So the domain for this, you can see that it goes forever to the left, this function over here, forever to the left and forever to the right. And I'm talking about G, which is the main function. In other words, domain for G, G of x is equals to 1 over 2 to the exponent x. So the domain is just going to be what? It's just going to be what? I hope you said x element of real numbers, because it goes forever to the left and forever to the right. And you can already predict the range for G of x, which is the logarithm of x at base 1 over 2. You can already predict the range for this. Okay, and remember the domain of the main function is basically the range for the inverse. Okay, it's the range for the inverse. So the range is just going to be y element of real numbers. Easy, isn't it? And then what's the domain? I mean, what's the range for the main function? The range, obviously here we're talking about the y values. We know that, okay, y values cannot go beyond the x-axis, which is 0 there, meaning that y values will always be positive. Okay, y values will always be positive. And if you check, y values are actually not allowed to be 0, right? Because this function here never touches the x-axis. So the range is going to be like this: y is strictly greater than 0, because y is not allowed to be 0. Once your y is 0, then we're going to have issues. So y is greater than 0, and y is an element of real numbers. Okay, so I mean, this is going to become the domain of the inverse. So the domain, we don't even think about it too much. X is greater than 0, x is element of real numbers. Easy, right? Yeah. So guys, I think we have covered enough. Yes, I don't know what we're gonna do next, but I'll have to think about it. Maybe we might find some, you know, past papers that we can actually look into. I don't know if this is the right time, because we still got, you know, some chapters that we actually gotta look into, especially trigonometry. So I think it's best if we start off by going through that trigonometry, and then we start with past papers, because we shall have completed the entire, you know, syllabus for term 1, because we've covered number patterns, with geometric series, this and that, you know. We've also covered functions. Now we're left with trigonometry, one of the most, you know, interesting chapters as well. So you should expect trigonometry in the next couple of days. So let's go. Peace out.